right, class, so we're going to do the final installment of the final exam review. We will pick up with number 48. 48 says to find the component form and magnitude of the vector v. All right, and part A has initial point 7, 3, and terminal point 6, 7. All right, so to find the vector v, all right, we do the x-coordinate of the terminal point minus the x-coordinate of the initial point. So 6 minus 7 is -1. 7 minus 3 is 4. Right? So to find the magnitude of v, we take the square root of a squared plus b squared. So this is simply the square root of 17. Right? B will work exactly the same, except actually we don't even need to worry about b because it is a three-dimensional vector. So 8, 3, -5, which we never did, although quite frankly you just do the exact same thing. But we don't need to do this since it's 3 dimensions. That will not be on your final exam. All right, 49. For the following vectors, find A, u plus v, B, u minus v, C, -4u, and D, v minus 4u. Then sketch each resultant vector. Okay, so we have u is equal to 1, -4, and v is equal to 3, 6. All right, so A is u plus v. So we literally just add corresponding components. So 1 plus 3 is 4, and -4 plus 6 is 2. All right, B, u minus v. So 1 minus 3 is -2, and -4 minus 6 is -10. All right, C, -4u. So I just multiply both components here by -4. So -4, 16, and D, we have v minus 4u. Well, we already have -4u here, so really I just have to do v plus c here. So 3 plus -4 is -1, and 6 plus 16 is 22. Now the directions say to graph these. Of course, all you have to do is start at the origin and then put the end point here. So 4, 2, right? Like A could be somewhere up there. B, -2, -10 would be way down here somewhere, right? You always come out of the origin, right? -4, 16 would be way up here somewhere, right? I'm not going to worry about doing all of these because, again, this is a multiple choice test, so you're not going to actually be graphing these things, but that's how you would do it if you wanted to. All right, 50. It says find a unit vector in the direction of the given vector, and v is equal to 7 and the square root of 15. All right, well, to find a unit vector, all right, all you have to do is take the given vector and divide it by its own magnitude. All right, so the magnitude of v is going to equal the square root of 7 squared, which is 49, plus the square root of 15 squared, which is 15. So this is the square root of 64, which is 8. All right, so now what I'm really doing is 1/8 times 7 and the square root of 15. All right, so this will equal 7/8 and the square root of 15 over 8. Done. 51. All right, find the angle theta between the two vectors. U is equal to 7, -6, and V is equal to -3, -9. All right, now the formula for the area between two vectors, all right, which will be on the formula sheet that I give you, all right, is going to be cosine of theta is equal to U dot V over the magnitude of U times the magnitude of V. All right, so let's find all of this stuff. First, U dot V is going to be -21 plus 6 times 9 is 54. So this would be 33. The magnitude of U will equal the square root of 49 plus 36, which is the square root of 85. And the magnitude of V is equal to the square root of 9 plus 81, which is equal to the square root of 90. Now, there's no need to actually simplify these out. Of course you can if you want, but you're just going to be plugging it into a formula anyway. So theta is going to equal the inverse cosine of U dot V, which is 33, divided by the magnitude of U, which is the square root of 85, times the magnitude of V, which is the square root of 90. All right, you plug that into our handy dandy calculator, and you will get 67.8 degrees. And we are done. 52. All right, find the projection of U onto V. All right, so the projection of U onto V, we have a formula for that, which is U dot V over the magnitude of V squared times vector V. All right, so if V is 3, or I'm sorry, if U is 3, -2, and V, that should be a pointy bracket, all right, and V is 7, 1. All right, then first I need to find U dot V, which is going to be 21 plus -2, which is 19, and the magnitude of V squared is equal to 7 squared plus 1 squared, which equals 50. All right, so plugging it into this formula here, we're going to get 19 over 50 times my vector V, which is 7, 1. All right, so 19 times 7 is 70 and 63, so that's 133 over 50. And 19 over 50 times 1 is simply 19 over 50. So there's our projection of U onto V. 50, there is no 53, so 54. It says solve the quadratic equation. All right, going back in time. All right? So a equals x squared plus 169 is equal to 0. Right, we can actually do this using square roots. Right, we have to take the square root here, all right, which normally we can't do the square root of negative numbers, but this is just imaginary, so this would just be 13i. Technically it would be plus or minus, but whatever. All right, b, we have, we have x squared plus 4x plus 6. All right, this isn't going to be factorable, and it's not even going to have real solutions, but we can still do x is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2 times a. So we get negative 4 plus or minus 16 minus 24 is negative 8 over 2. So this is going to be negative 4 plus or minus 2 square roots of 2i all over 2. All of this is divisible by 2. So negative 2 plus or minus the square root of 2i. I probably won't put those any on the final exam, but they're really easy anyway. All right, 55. Write the complex number in trigonometric form, and we are given negative 3 plus 7i. All right, this is what we just did, the most recent thing. So this is my a, this is my b, right? Of course, I is not included in the a or b. All right, we know that r is equal to the square root of a squared plus b squared. So this is going to be 9 plus 49, which is 58, right? I don't believe that that can be simplified any. All right, then we also know that the tangent of theta is equal to b over a. All right, so of course we just need to do our inverse tangent here. And when we take the inverse tangent of negative 3/7, we get negative 23.2 degrees. Okay, now we need to see if we were to graph this thing, right? Negative 3/7 would be up here somewhere. Negative 23.2 is down here somewhere. All right, so we know that we're going to have to add 180 to this. All right, and when we add 180 to that, we get 156.8. All right, which makes sense, right? If this is 90, we go further. Okay. So now we know that our trigonometric form of a complex number is r times cosine theta plus I sine theta. All right, so for us, that's going to be the square root of 58 times cosine of 156.8 plus I times the sine of 156.8. All right, so there is our solution. 56. Perform the operation and leave the result in trigonometric form. So we have 4 times cosine of pi over 3 plus I sine of pi over 3. And we are multiplying that by negative 7 times cosine of 5 pi over 6 plus I sine of 5 pi over 6. Okay, so when we're multiplying numbers in trigonometric form, again, this formula will be on the sheet that I give you, but it's really easy. All we do is multiply the r's, so 4 times negative 7 is negative 28. And then we add the thetas. This is really just 2 pi over 6. So 2 pi over 6 plus 5 pi over 6 is 7 pi over 6. So cosine of 7 pi over 6 plus I sine of 7 pi over 6. And we are done. (57). Now it wants us to divide. We are dividing 5 times cosine of 130 degrees plus I sine of 130 degrees, all being divided by 35 times cosine of 95 degrees plus I sine of 95 degrees. Okay, well, when we divide the r's. 5 over 35 reduces to 1/7, and then we subtract our thetas. So 130 minus 95 is 35. That's it. We're done. And last but not least, number 58, de Moivre's theorem. All right, we have 2 times cosine of 4 pi over 15 plus I sine of 4 pi over 15. Right, and that's all being raised to the 5th power. Right, so de Moivre's theorem says that all we have to do is take our r and raise it to the 5th power. This for aesthetic purposes. All right, and we will now have cosine, and now we take this power, and we multiply it by this. So 5 times 4 pi over 15 plus I sine of 5 times 4 pi over 15. All right, so 2 to the 5th is 32. Cosine 5 times 4 pi over 15 is 20 pi over 15, which is 4 pi over 3 plus I sine of 4 pi over 3. And we are done. That concludes the review for the final exam.